a bit like a science lab. Understanding the science of cooking helps you make food taste as it should. So why does food behave as it does when we cook it? And what's going on in our head when we eat it? In this episode, The Chemistry of Chocolate, visit a spectacular chocolate shop, sample chocolates fit for kings, and journey deep into chocolate's molecular heart. This is l'Artisan du Chocolat in London, the chocolate shop of Gerard Coleman, my favourite chocolatier. For many of us, from childhood on, chocolate is a special food. Chocolate's made from cocoa powder, cocoa butter, sugar, and an emulsifier which stabilises the chocolate mixture. Most of us love chocolate. Understanding how it's made in the first place will help you make wonderful chocolate dishes at home. Most people get scared when cooking with chocolate, mainly because when it goes wrong, it goes really wrong. Now I'm going to try and boost your confidence by showing you just how to get it wrong and what it looks like when it does go wrong. This may seem a bit mad, but understanding how it goes wrong will help you to get it right. It's all about careless melting. Here we've got some chocolate in a bain-marie. All a bain-marie is a bowl set over a pan of water, simmering water, and then just stir. Just make sure that you don't overcook or overheat the chocolate. That's it. One end of each emulsifier molecule sticks to sugar or starch particles. The other end sticks to the fats from the cocoa butter. That's how they bind the components of chocolate into a stable emulsion. There you are. Take it off now, you have no problem whatsoever. If you leave it on, however, completely different kettle of fish. When you overcook chocolate, the emulsifier, stabilising the whole mixture, is destroyed, and the solid particles just clump together. That's why this has got so dry and grainy, it's inedible. Irretrievable, wrecked chocolate. It's burnt, it's become granular. Pasty. It's lost all of its velvety texture. It's effectively cooked. You're best off just finding the bin or maybe a pet that might want to eat it. So now, an extraordinary new recipe. As a chef, you're always told that water is an enemy of chocolate, seizing it up and making it go grainy. This is nonsense. I'm going to show you with this recipe how that doesn't hold true. This dish, chocolate chantilly, was invented by a French chemist named Hervé Disse. First, put water in a pan, add chocolate to the water and whisk while heating. Take a bowl with ice in it and put another bowl on top, pour in the chocolate. And then the vital part, whisk like fury. Normally, the addition of water unbalances the structure of chocolate. It makes the solid particles of sugar and carbohydrates clump together, making it all grainy. But whisking turns that on its head by making the water drops very small. These droplets coated with emulsifiers then stabilise the mixture. It's just starting to take on the appearance of or thickness rather, of double cream. Chocolate-flavoured cream. You see, as I whisk further, it's thickening more. There, it's just about there. If you look now, it's taking on the thickness of lightly whipped cream. A tiny bit more. That's it. It looks like chocolate mousse. Look. It's delicious because there's no cream in it, so you're getting the real purity of the chocolate. Ultimately, all chocolate is derived from the cocoa bean. But even a chocolatier like Gerard Coleman doesn't start with a bean. He starts with huge bars of chocolate imported from abroad. But how does the bean become the bar? To help explain just where chocolate comes from, I'm joined by physicist Peter Barham. We begin by grinding up cocoa beans into a fine powder, doing on a small scale just what they do in factories abroad. It's starting a pasty.
Yeah, that's right. It should become a paste, and that paste is what's known as cocoa mass. It's whole cocoa bean that's been ground so fine, the cocoa butter, which is the fat part, has melted and coated it all around, and you can actually eat that if you want to. I mean, it's almost like a bar of chocolate, but of course it tastes quite different.
Bitter.
There's no sugar in it whatsoever at this stage.
So we've done basically replicated what they'd be doing in processing cocoa beans. Very simplified version, and it's also quite hard work using your arms. But if you have a look, just have a look in there now, you can see that it's become pasty. So we get this cocoa mass. And if I run my finger along it, it's actually coming off.
Yeah.
Manufacturers separate the cocoa butter from the cocoa powder so they can increase the proportion of butter later. Otherwise, there won't be enough fat in the cocoa mass to incorporate the magical third element you need to sweeten it. So, basically, this and this come out of this. That makes a lot of sense now.
Okay, yeah. So, who in their right minds would mix these two things together? I mean, you've got fat, bitter powder, they're not pleasant. What you need is something else to make them taste good, and that is this stuff, sugar. That's the key ingredient. Now we add the sugar to the cocoa powder and the extra amount of cocoa butter that will incorporate it. The mix is then heated up. Of course, you let it cool down.
It's quite crude, but it's definitely resembling chocolate now.
Let's just try a bit.
So here it is, crudely made, but that's chocolate as we know it. And that can be set into bars. I think at this point I should just mention this stuff here. It's white chocolate. Now, contrary to popular belief, white chocolate isn't technically chocolate. We've just seen how to make chocolate by using cocoa butter, cocoa powder and some sugar. Now, white chocolate doesn't use cocoa powder. It's just cocoa butter and sugar. That's it. Once you know the chemistry of chocolate, it should hold no terrors for you. But if you're making chocolates you want to handle, or if you're casting chocolate into any shapes, then there's something else you should know about. Tempering. Here's that chocolate you just saw me make from scratch. It's now set. It's definitely not the best chocolate in the world, but I'll tell you something. I have tasted worse. We didn't temper it. That's to say, we didn't heat it, cool it, and reheat it to particular temperatures. And because it hasn't been tempered, it may taste more or less okay, but it's very hard to eat without getting yourself in a mess. So as a chef, we know the importance of tempering chocolate. Basically heating it up, cooling it down, heating it up again. We've seen why it's necessary, we've seen why it makes the difference, but there's still the actual chemistry, what is happening to the molecules in that chocolate is something that I need a bit of explaining for. So, Pete, can you throw some light on this?
Yeah, sure. I thought actually a good way of doing this is a chocolate I prepared earlier without tempering it. This is what I would describe as bad tempered chocolate. Shall I show you why? Right, if I pick it up, I'll do this one, shall I?
Okay,
I'll pick it up, right, okay, right. If I pick it up and hold it in my hand, very quickly it melts in my hand. You can see it's melting away quite nicely. And what I get is, my hand is covered in filthy chocolate, and I get bad tempered.
That was only after a few seconds.
A few seconds, yeah. It's really filthy chocolate. It's horrible stuff. You wouldn't want to eat a chocolate bar that was like that. If you're serving in the restaurant a nice petit four, and the customer picks it up and it melts in his hand, he's going to be really
bad-tempered chocolate.
Exactly. So you get bad-tempered chocolate. So that's no good at all. And that's what happens if you don't temper your chocolate. Just melt chocolate, stick it in the fridge, it comes up like this, and it is basically very low melting point. And that's what people at home, if they don't temper their chocolate, just pour their chocolate, melt it, pour it onto a mould or whatever they do, chuck it in the fridge, that's what happens. And they say chocolate's difficult to work with because of that. It's only because it hasn't been tempered.
So what exactly is going on with the molecules in there?
OK, testing it straightforward enough. This stuff melts at a temperature which is around about 18 degrees. The cocoa butter is what's in there that's melting. Cocoa butter forms crystals. You may not think of them as crystals, because you think of crystals being little diamonds you wear on your finger, but that is what's in there, some crystals. There are 6 different types of crystals cocoa butter can form, and they all melt at different temperatures. The lowest one melts at about 18 Celsius, a low room temperature. That's horrible. That's what's mostly in this stuff here, because we made it just by chucking it in the fridge.
To temper, you melt chocolate at 50 Celsius, cool it to 27, then reheat to 31. This destroys the crystals that melt in the lower ranges and keeps those that melt at around 34. They're the ones we want. Our untempered chocolate contained crystals that melt as low as 18, so it melted when we touched it. But chocolate like this has been tempered so it only contains cocoa crystals that are heat resistant and only melt at higher temperatures, so you can cast it into solid shapes that won't melt at room temperature, and the chocolate won't melt in your hand, but it will melt in your mouth. If you want to be inventive with chocolate, new equipment can help. Here I'm spreading melted chocolate onto an amazing recent invention, a hollow metal board full of antifreeze. So cold it's frozen solid, so the surface is well below freezing. It may be this works by extracting heat so fast from the chocolate that it hardens without crystallizing. Well, I don't know. I'm feeling quite artistic, so I'm going to give this a go.
OK.
Right, here we go.
So let's pick it up.
It's still flexible, so you can form it into any shape you want. Look at that. Look. That is bendy chocolate. It's like cake, isn't it? And then I'm just going to wrap it around this cake.
Oh, wow.
Yeah. I'll just put that. Turn it around like that.
So now you've got sort of... Oh, so you can make any shape you like out of that, presumably. Yeah.
In part 2, an astonishing new flavour combination and a startling new scientific theory that may explain why it tastes so good. Now we've seen the basic chemistry of chocolate, we can start to experiment with new flavour combinations. I'm going to show you a spectacular dish that really is quite simple to make at home, I promise you. The basic concept of this dish comes from a great French chef, Michel Bras. I've then added my slant on it and combining chocolate with blue cheese. Don't balk, it does work, it really does. First, the ganache. Combine whipping cream with cracked coffee beans and some fresh espresso. Bring to the boil and immediately remove from the heat. Add some blue cheese, a mixture of Roquefort and Bleu d'Auvergne. Whisk till it's dissolved and the mix is smooth. Strain this through a sieve onto some diced butter and chocolate. Stir until melted. I'm just incorporating the chocolate with the blue cheese, butter and coffee. It takes a few minutes as you don't want to subject the chocolate or the butter to too high a temperature. So I'm just letting it melt slowly. Should take about 5 minutes in total. Okay, it's now all melted. That's ready to pour into the container and stick in the freezer. And now we're going to make the casing. In a mixing bowl, combine egg yolks and sugar. Whisk till the mix whitens and significantly increases in volume. Combine more bitter chocolate and butter in a bowl and melt gently in the microwave. When the egg and sugar mix is ready, gradually pour the melted chocolate and butter over it and whisk until completely mixed. Sift a little flour over the chocolate mix and fold in. Take small buttered ring moulds, place on a baking tray and line with silicone paper. Spoon enough chocolate mix in to cover the base. Remove the frozen ganache from the freezer and cut it into squares. Place a square in each ring mould and cover with more chocolate mix. Put in a preheated oven at 190 Celsius. They've been in the oven for 10 minutes. Time to get them out. To remove from the moulds, run a small sharp knife around the inside edge. Cutting releases a river of molten chocolate and blue cheese. That's why the French call this chocolat coulant, flowing chocolate. That's really good. But why chemically does the combination of blue cheese and chocolate work so well? Can science help explain this and perhaps come up with some new great flavour combinations? Next stop, Geneva. We're off to see one of the world's most accomplished flavourists, and we're going to talk to him about this very subject. Firmenich in Geneva, Switzerland, is one of the world's biggest manufacturers of flavour and perfumes. I visit whenever I can to swap ideas and discuss kitchen chemistry. Scientists here have been developing amazing new technology to push forward the science of flavour, so we can start to answer questions that have puzzled scientists and chefs for centuries. Like, why some food combinations taste so bad, and others, like chocolate and blue cheese, so good. To analyse the flavour of blue cheese, the scientists use a needle coated in super-sensitive absorbent powder. Volatile molecules containing the flavour fly off of the cheese and stick to the powder. The needle's put into a mass spectrometry machine, which processes the flavour molecules and produces an analysis of them in graph form. The first peak here is butyric acid, which helps give cheese its buttery note. The second peak here is an ester, which gives cheese a fruity note. There are hundreds of flavour molecules, not all visible, in each foodstuff. This is a map of many of blue cheese's flavour molecules, showing the relative intensity of each one as it's released. This is the laboratory of Francois Benzi, chemist and flavourist. It's his job to produce new synthetic flavours. Amazing. So here, from one of the top flavourists in the world, is the reason why blue cheese and chocolate work so well together.
In fact, the reason is due to the similarity of many of these molecules, which we find on one hand in the blue cheese and on the other hand in the cocoa. Look at this. For instance,
Francois showed me a breakdown of the molecular profiles of chocolate and blue cheese. Marked in yellow, all of the molecules they share, including a host of ketones composed of carbon and oxygen.
Ketones, in fact, are chains of carbons with oxygen linked with a double bond. And they give generally very fruity or blue cheese character. Many ketones are also found in fruit flavors, in raspberry, strawberry, but berry flavors.
In cheeses and fruits, yeah, but in chocolate, if you look here, there's over 60% of the ketones in blue cheese are also in cocoa.
Yes.
And you wouldn't have expected that much, would you?
No. There are quite a few molecules in each group which are exactly the same.
I think also for me, what I like so much about this is there is evidence. It's on paper, you know. It's no longer an arbitrary thing that it comes down to somebody's palate. Okay, some people may like it more than others, but it throws light on a whole new world of possibilities, isn't it?
Certainly. When you see this, suddenly it's a brand new taste world which is getting open, and you wonder. I think maybe a person like you is just starting to put the finger in this new kind of possibilities.
So here you have it, chocolate and blue cheese, and there is a chemical molecular reason why they taste so good together. Science can also help you understand why certain ingredients just don't go together. I'm going to take some basil. That's fine. And now I'm going to have a sip of coffee. Oh, that's foul. Those two ingredients should never be put together. That is disgusting. But we now know it's because they have completely incompatible molecular profiles. If you don't believe me, try this at home. But please, don't blame me. Blame the molecules. At my restaurant, we often serve, as part of the tasting menu, white chocolate with caviar. An odd combination at first sight, but we now know they have very similar molecular profiles. Food for thought. And now for a Fat Duck special, délices of chocolate. I love surprising people when I cook. And this dish, the element of surprise comes not from an unusual flavour combination, but the way that the flavour and texture is released in the mouth. Now in this dish we house popping candy in a crunchy base. It's disguised within the base itself. First, melt 20 grams of chocolate, then add the praline, a paste made from pureeing roasted hazelnuts. Combine this with caramelized pieces of puff pastry and a little milk chocolate, and finally the popping candy. This mix is lightly pressed into the bottom of individual ring molds and left in the fridge to cool and set. That's the base. Now the ganache, the centre of the dessert. Bring the cream to the boil and pour it onto the chopped chocolate. Then add softened butter and let the whole thing melt. Once it's cooled down a little but is still runny, pour it into the rings containing the popping candy and the biscuit base. Once they've set in the fridge, take some tempered bitter chocolate and dip a strip of plastic into it, so it's coated on one side. Then wrap it around the délices using the softened chocolate as a glue. Once that's hardened, top with glaçage miroir, chocolate glaze. Put the desserts back in the fridge. Meanwhile, make the cumin caramel sauce. Put sugar, cumin and cinnamon in a pan and cook until a golden caramel. Add butter and cream and bring to the boil. When everything is blended, pour this sauce through a chinois, a fine sieve, to remove the spices. Leave this to cool. Now, to make the shards of pulled caramel, made from melting sheets of fondant, glucose and cocoa powder. Roll the sheet with a pin, then pull a corner of the caramel gently so it stretches as thin as possible. Be careful, because if the caramel's too hot, it'll be too liquid and just come apart. If it's not hot enough, it'll snap before stretching and be too thick. To plate up, first the caramel and cumin sauce. Next, the chocolate délice with the plastic strips removed. A twirl with nibs of chocolate. A spoonful of chocolate sorbet. And finally, a shard of stretched caramel. And there you are, chocolate délice, containing 7 forms of chocolate.